Good morning, everyone, and thank you for joining Oasis Sales and TriLogic for our Did You Know webinar series. Today's webinar is called Industry 4.0 and Design Verification. I'll go over the details of that here pretty soon, but let's go ahead and get started. It's 9:30. So just a couple introductory slides here. So a little bit about Oasis Sales. Oasis Sales has been a premier partner with Mentor Graphics for over 18 years. We provide technical experts like myself in helping our customers with any of the CAD tools that we sell. We pretty much sell everything from Mentor Graphics. We are in the Midwest. You'll see that here in a second. And then we have TriLogic, one of our partner resellers on the East Coast. Same thing. They've been a partner with Mentor Graphics for 30 years. And provide technical expertise in all of the tools sold by Mentor Graphics, plus some additional products as well. And these are kind of the territories that we cover. TriLogic's on the East Coast and Oasis Sales in the Midwest. If you're joining us from any one of those states, those would be those particular resellers that you go and join or request information from. All the webinars that we put on each month, whether it's the Tech Talks, Did You Knows, or other webinars, we do post out on our YouTube channel. You can go to YouTube, Oasis Sales Tempe, and you can see all of our previous webinars that we've done to date. And TriLogic likes to post theirs on their website, so you can go to their website and see all the webinars that they've done in conjunction with Oasis Sales. Our next webinar is going to be Design Rules Routing Automation equals shorting your design schedule. So if you want to learn more about how to create design rules in the PADS tool flows and how they can help you use automation to get your designs done faster, please join us next month on Thursday, September 13th for PADS and PADS Professional. And again, we are available for you to assist with any technical questions you may have, along with Mentor Graphics. My name is Brent Klingforth. Here's my email and phone number. You can get a hold of me anytime with questions you may have on any of the tools from Mentor Graphics. Just a quick how to go about asking questions since I've got everyone on mute. There's a little chat window down in the webinar control panel. Just type in your question there, please, and I will reply back to that question for you as soon as I can. Now, during the webinar, I'll probably continue on through the webinar, but please type in any questions you may have, and I will answer those at the end. All right, well, let's go ahead and get started. So again, today we're going to be talking about Industry 4.0. Many of you may have heard this term, reading articles either in the public chat forums or the magazines, electronic engineering magazines that are out there, just in news articles. It's becoming kind of a big deal here as we move into 2020 or even just mid 2015 on. This is becoming a much bigger deal in the industry, and I'm going to explain a little bit of that here in just a second, and how you can take advantage of that and what it requires for you to really take advantage or become part of what is that Industry 4.0. All right, just a quick overview of what that is. As you know, Mentor Graphics was acquired by Siemens a couple years ago. And Siemens had this philosophy very similar to what the rest of the industry is now calling Industry 4.0. They call it the digital twin. It started even long before the Industry 4.0 terminology was brought about. But basically what Industry 4.0 is instead of doing everything the way we've done it over the last 20, 30 years, where you build a product or you design a product and you build physical thing to play with, and you build a physical environment in which to build it in, and deal with all those issues that come along with, well, I didn't get it right the first time, I got to make this tweak here, in order to make something happen. What Industry 4.0 is in digital twin is basically there's tools out there today, some of these you may not be aware of, and that's what I'm hoping to introduce you to here in this presentation, is you can do everything from the product design phase all the way through production and services with simulation. It's probably kind of hard to believe, especially when we get into the production through services side of things. I'm not going to go into a lot of detail on that, but I will describe things that are there, and Siemens is definitely leading the way in this part of the industry. I'm going to talk a little bit more based on just product design, but in the production planning phase, there is software to help out with, work instructions, quality information, doing production simulation. Believe it or not, you can actually design, and some of you may be using these at your company. You can actually design a production floor and set up all the motions and the assembly process for putting together that product that your company makes. So you can completely plan out before you ever physically build a production line or even a production plant, all of that process with simulation to find out what is the optimal way for us to manufacture our product. Okay. On top of that, there's product engineering, configuration, validation, and virtual commissioning. What this really is, and many of you out there are using these tools today, and they are, data management tools basically. Now, some of those data management tools are broken, believe it or not, from the Industry 4.0, meaning they concentrate or they don't tie in specifically to the tools that we as engineers or production planning or production or services, actually the tools they use to do their job aren't necessarily tied into the full team center, or not team center, but the entire, product lifecycle management environment. Okay. So on the Siemens side and some other tools, you'll hear programs by the name of like Team Center. Team Center has the ability to tie into all these different phases of the product creation. So from product design through planning, through production, through services, all the data that you produce can live here in that domain for everyone to have access to and make decisions on very quickly on how to handle issues or new ideas that come up, so that you're not having to try and get together with meetings, produce reports, or work through different systems in order to see that data and produce an end product in a timely fashion. All right. So again, on the production side, there's monitoring your production, doing optimization of your production processes, and then services, dealing with documentation, maintenance, monitoring conditions, dealing with service requests with customers out there, and having, again, all that linked back all the way to the product design. So as soon as the product is starting to be developed, people can start, planning out the production process. They can start doing all the configuration management because they start seeing that data in that system. That's really what Industry 4.0 is. It's doing things in more of a digital space beforehand, instead of relying on paper and discrete systems to handle all of that data. And, over the years, and if your company's still working that way, it takes a long time sometimes to make things happen or find information to get things done, where in an Industry 4.0 digital twin philosophy, all that data is tied together and the systems all talk through that system in order to make decisions happen quicker. So that's kind of what we're going to be talking about today. I'm going to be concentrating really on the product design side of things. Siemens has a bunch of webinars out there related to these other fields, that you can search for and watch archives on or register for future events on top of that as well. So let's go ahead and move forward here. So again, I'm concentrating on what types of tools you as engineers can use in the product design phase to not have to produce a physical prototype in order to validate your design that you're working on, or solve a question about, is this going to work the way I want it to? That can all be done in simulation, and I'm sure many of you out there are using some of these products, but I seriously doubt everyone out there is using all of this capability, from electrical design through mechanical, and even into documentation type things. So I'm going to go through these in more detail here. You'll get a better understanding of what's out there, and maybe you'll have some interest in one or two of the products that you didn't know about, and that's what we're here to help you with. Educate you more on those applications and how they can help with your design flow process. All right. So the first one, electrical engineering. This one's actually, as we know, has been around a long time. Many of you out there are doing this. I've talked to hundreds of customers a year, and they're all doing some type of analog simulation in their designs, but they're always using a discrete system. So they're using one tool for doing their schematic, and they're using a completely different tool for doing their analog simulation stuff in. Maybe because that tool is free, or they have some old licenses of something else, and or they didn't know that some integrated capability was there. So on the Mentor side, we do have an integrated tool. It's built into our PADS Designer product flow. It's called PADS AMS. To let you know as well, for those out there using some of the free tools, there is a PADS AMS free application as well that you can go to. I will put a link on our YouTube channel where to go to for that if you're interested to gain access to that. The advantage of using the Mentor application is that data can be more easily migrated into a schematic tool that you may be using from Mentor Graphics. Now, granted, if you're using, say, Altium or Cadence or some other tool for doing that, you're still going to be able to use it as a free environment for doing your stuff. But most, as you know, all or most free environments are somewhat limited in some way, where if you can use a tool that is integrated into your schematic capture application, you'll have more functionality and capabilities. So that's where our PADS AMS tool comes into play. You have full analog or SPICE simulation capability, plus it adds the capability of what's called VHDL AMS, if anyone out there has heard of that. VHDL AMS is a language-based way for you to create a behavior model of an analog device. It's very useful for doing things that normally a SPICE model is difficult to create for, like switches, speakers, relays, inductors, transformers. Those types of things can all be handled with the behavior model, and our PADS AMS tool provides that functionality. So having an integrated tool allows you to reduce redundant work, capture the schematic directly in the same environment, assign the various types of models, set up your simulation parameters, Monte Carlo analysis, worst case scenarios, do those simulations, and go back into your design, make adjustments real quick, and continue on. You don't have to recapture any of that. If you're using one of the most popular tools out there, LT Spice, you have to do your simulation, and then you have to go back into your other schematic tool, make the change, and then go back over there again and make adjustments and do a simulation. So being in one environment to do all of that, again, puts you in a place to make much faster decisions and move on more quickly. So again, not sure if you knew that this PADS AMS product was out there. That's kind of what these webinars are for, is to help educate people and introduce them to technology they may not have been aware of. Moving on, configurable electronics is always the second one. Again, this has been around for some time as well. Most people use VHDL or Verilog for some type of FPGA creation. These languages are also used for doing ICs and ASICs as well. The problem is when I talk to customers, most of them are just using the basic side of these simulation tools. In other words, they're just simulating the tool, looking at waveforms, making sure it looks right, but they're still taking that code, burning it into an FPGA, and then running it on a physical board, right? You can't run an FPGA in a virtual environment per se. You don't have rest of the electronics there to do that. There is some technology out there to do that, but most people are building physical boards with their part on it, burning their code in there, and then making sure it works in their prototype environment. Well, there's really no way to do that. A lot of engineers have started to adopt the philosophy of OVM, UVM verification. Many of you have probably heard of this capability of verification, but it really increases or adds a lot of functionality to make sure that all of the code you've written is 100% going to be verified without having to go to some physical board in order to test that. So the task can be a little daunting. That's probably the big reason why a lot of people don't move into OVM, UVM, is they've learned that it takes a lot of work to set up the environment, set up all the test benches and stuff to make it work. Again, Mentor's leading that front. You can go out to, I'm drawing a blank on the name now, Verification Academy, and they have classes, free classes out there for you actually to go to, for those that are doing HDL-based designs, where you can learn more about OVM, UVM, System Verilog, System C, some of the more advanced capabilities that are available in the tools for doing FPGA analysis. And Mentor has set up tools that can automate or simplify the process of setting up your environment for doing OVM, UVM. So most people are doing huge designs, 20,000 lines code plus, into the hundreds of thousands, have been doing this for some time because you have to. It's too hard to verify your stuff by burning it or running emulation codes if you're really doing big designs like ICs, microprocessor design, things like that. But for you doing smaller designs, 1,000 lines of code or so, you may have thought this was just too much work. It's something to start investigating because those environments are definitely getting easier to set up. There's more test bench code out there available, IP for you to download and use for test benches, and use this environment, right? Let's move on. Advanced schematic validation. Now, this is a new application that was just acquired by Mentor Graphics, actually called Validate. I decided to put this out here because it is some really cool technology that instead of the process of going through and analyzing or reviewing a schematic design of even a small board, but most of them are reasonably sized, 500,000 parts plus schematic electrical designs. You have to go through some type of engineering review of that design, right? And that takes time. A lot of manual inspection, time-consuming meetings. You can go ahead and, you go through these meetings, you check everything, but then you go through and you produce the board and you still find out something doesn't work. We missed a pin, hooked something up wrong. We had outputs tied together, all outputs tied together, all inputs tied together. But some of the tools have basic checks for that kind of stuff. But this advanced schematic validation brings a whole new level of verification to just the schematic level and helping you determine your design intent and making sure that you don't create any of those small or types of violations that you may have seen. So again, Mentor acquired this tool just recently. It's under the Mentor name now, but the company is called Validate. You can find out more on the Mentor website on this product, or give some someone at Oasis Sales, myself, or TriLogic a call, and we can help you learn a little bit more about this application, how you could use it, and possibly put it into your design flow and take advantage of schematic design rule checking. This is kind of like the Valor of PCB, but for schematic design. Okay, and we all know PCB verification is done at fabrication and assembly levels to ensure the product's going to be built right. Well, why not do the same thing at the schematic level so the physical board is built right? All right. High-speed interconnect. Again, these tools have been out there for some time, but again, I've talked to a lot of customers that choose to do this type of verification by hand still, or off of vendor tech notes or rules of thumb, those types of things. Well, as you start to get into more and more high-speed design, you're going to need to start doing simulation. There's things in the SerDes space that, yes, you can get away with certain things, and if you really pay attention, but when you really pay attention and do those things and do manual verification, you've taken X amount of time to get that done, where if I had just set things up in a simulation environment, I could have validated it much quicker, done it right the first time in the PCB and moved on, and not had to spend all that time making sure I had it right. Things like verifying your stack up, checking critical nets for termination or signal quality. The tools are very advanced now, and as anyone knows that use hyperlinks, it's still a very easy tool to use. You don't have to be an SI expert by any means to use this application in order to validate your high-speed nets, whether at a schematic level or the PCB level. All right. This also helps you as an electrical engineer define the PCB design rules that need to be entered for the layout instead of guessing. Okay. Moving on to the more mechanical side of things, or getting into the physical board side of things, we have MCAD Collaboration. Again, I talk to customers that do use this. Technology's been there, but then there's a lot of customers still that are doing stuff with AutoCAD drawings, importing DXF files into the PCB space, even using IDF, which is still great. It does automate some of the process of creating a board outline, placing original parts, but then you have to give back, an IDF and the mechanical world, and they have to open it up, and then they make a judgment or move something, then you have to try and bring it back into your layout tool. And IDF files don't allow you to import changes. You can only import everything all at once. So there's tools out there provided with the major mechanical engineering applications and the electrical engineering tools called MCAD Collaboration. This uses a new standard called ProStep in the industry. It's been out again for a while. And again, some of you may be using it, but for those that aren't, this capability is there to allow you to perform actual changes between the mechanical space and the electrical PCB space. So it's bridging that gap. You can now start making just a single part change or a single board outline change or move a component with this capability. All right. So again, it makes the process of reviewing the mechanical with the PCB an easier way to verify if you have any clearance fit problems, or you're 50%, 60% through the way design phase, and the mechanical engineers decide they need to add something. Maybe they've done thermal simulation and they had to add a heat sink on a part, or they had to add some heat sinking, heat piping or something like that. They had to move some components around or add some features to the board, and you're halfway through, doing that design. It can be hard to add those types of things and get them in the right location, where by doing collaboration, they can bring in quickly the model of your design. They can move those items. You can bring it back. You can view and verify those changes. You can say, well, based on what I've done, is that going to affect me tremendously, or I'm not going to be able to do something? So let me make adjustments to that slightly. You'll be able to see that using the collaboration interface and more intelligently make those decisions and converge on a solution between the two of you and move on very quickly. So if you're not using this technology, again, especially those out there using our pads product line and even Expedition, this collaboration interface is included with your application now. If you're on our most recent VX release of the tool with VX 2.3 licensing, you have this capability for free. You no longer have to pay for this capability like you've had to in the past. So by all means, let us know if you need any help with this. We've done some webinars directly on this, and we can help you get this set up and show you how it works. But it's a great way to streamline the communication between MCAD and PCB world instead of doing things kind of the old-fashioned way, which is, again, the whole idea of Industry 4.0 and the digital twin, doing things more interactively with digital communication instead of doing it manually. So thermal verification, you may be using some of this stuff, but the thermal verification tools that are out there today have become much more simplistic to use. And people may think of ANSYS when they talk about CFD or FEA analysis. Mentor owns some of the best technology in the industry, for doing that type of simulation, and the tools are made much easier to use. So you, as an electrical engineer, do not have to be an expert in CFD or FEA. Even the PCB designer, you don't need to be an expert in that environment in order to take advantage of setting up and doing thermal analysis on your physical designs. Even mechanical engineers, a lot of times they have specialists within your company that can do this. Well, a lot of companies, the engineers are being required to do more, and that's where, don't be afraid to, step into one of these CFD or FEA tools and start playing around with it and see if it can help solve your issues without trying to guess, or again, build physical prototypes to test your different heatsink or fan or enclosure designs to see if it's going to solve your thermal problems. That just waste time, and you're gonna be late more than likely on your product. Or if there was a lot of time built into the schedule for that, you can be the hero by bumping up that schedule and finishing that project, several weeks to months in advance by taking advantage of, again, simulation technology to solve those difficult problems related to thermal aspects of your design. All right. Electrical sign-off, this is kind of a new thing. Mentor is actually leading the way. Many of you probably don't know about this capability. Electrical sign-off for a lot of companies is sitting in a meeting with people, or passing designs around and sitting there looking at the board in a viewer, making sure your high-speed traces are all routed perfectly, and there's no splits in planes, there's no traces too close to a board edge, you've stitched the planes together right, you've placed vias in the right locations for high-speed signals transitioning between layers, you put decoupling capacitors in the right spots. All of that stuff is usually done in a manual viewing environment, but Mentor is leading the way with electronic tools to do basically DRCs on your designs for those things that you typically have to look at manually. Some of the tools that I've talked about, like hyperlinks, doesn't even have a lot of the technology built in to scan a board all at once and give you detailed information back about where you might have some violations. So a lot of people ask us, do you have tools for doing EMI simulation? And I say, no, there are tools out there. You've probably heard of some, but they don't really simulate the real world environment of EMI. No tool really does. It's a very, very, very difficult scenario to simulate due to its random nature and 3D physics. So being able to know what types of things cause EMI issues is very well known, and having a tool that can analyze that for you is very powerful. So being able to go in and analyze a design for things that could cause EMI issues and having the rules already there created for you. You just have to set up parameters on what you want to check. You can quickly analyze the design for probably almost 100% of things that you would normally do in a design review with other people, and looking at a board, in a viewer, or God forbid you're printing it out and looking at it that way. So being able to use an application to do electronic verification has been used by customers now for several years. This tool has been out for 3 or 4 years now. So it's continuing to be developed along very nicely. They're continuing to add new rules to the application. There's even capabilities in the tool, if you buy the right level of licensing, where you can write your own design rules. I see vendors out there starting to write rules, use it for the Hyperlinks DRC tool, and that customers can download and run in their environment for the specific chips they're using from those vendors. So, but customers are realizing 80% design verification reduction in time, and getting better answers back, finding things that they didn't find even during a physical or manual review. All right. So this tool does do checks that are in the PCB or SI tools, but again, it doesn't typically do them from a global level. So the entire design, or you can pick nets that you want to particularly do, but there's a lot of things this application can do. I'm just giving you kind of a highlight of the technology that's there. Mentor has quite a few webinars and information out there that's available on Hyperlinks DRC and what it's capable of doing, how it can be used to ensure first-time success in your designs. And a big one, again, doing some EMI-related verifications that a lot of people ask about, and no other electronic tool vendor can really give them an answer on those questions. But Mentor Graphics, Oasis Sales, TriLogic can provide a solution for you to help answer those questions. So moving on, again, high-speed interconnect validation. We talked about this from the schematic side a little bit earlier, but this is more from the PCB side. There's a couple different applications that live in this space. There's actually signal integrity, and then there's also power plane analysis, both AC and DC. But again, a lot of this type of stuff people will try to do using like spreadsheets to calculate that. The PCB designer will try to methodically look at their plane areas and see if they have enough copper in there based on the known current flow that's going to go through the planes. Why not just make it easy? The DC drop analysis tool is very simple to use. Any PCB designer out there can set it up and run it on their design. After they get done creating planes and putting all the vias in and stuff in their designs, they could go do an analysis real quick and find out if they really did allow enough copper for a given current requirement from source to load, or from source to load in the design. And then of course on the high end side of signal integrity, Hyperlinks is very well known, but being able to validate all of your high-speed signal nets. This is the one thing that, again, a lot of engineers I don't think fully understand, is that any signal that has an edge rate of faster than 1 nanosecond could cause signal integrity issues on your board, depending on how the size of that design and how long the traces are routed around the board. So being able to just even look at signals that fall into that range and verify them can be a powerful thing. I mean, you can end up with EMI issues. You can end up with random production failures because of signal integrity problems. And when those things happen, it's going to require tens to hundreds of hours to debug and fix those problems, when you could have a tool at your fingertips to solve that problem very quickly and know about it before the design is ever produced. That's again, the whole idea of simulation. Figure out your problems and come up with a solution long before you ever build your design. All right. So things like, doing optimization on termination, optimizing via placement and high-speed signals, optimizing your SerDes signals, via pre-emphasis equalization in the channel, doing bit error rate simulations, looking at VIA models in a 3D environment and getting accurate simulation results. Those are the types of things that are available to any electrical engineer out there. You don't have to be an expert in 3D field solving space to use these applications. All the automation is there to make this process of doing high-speed SerDes validation very quick and easy. Along with, I didn't throw any DDR stuff up here, but the DDR channel analysis as well can be done using wizards. Set everything up, let the tool do all the work for you, come back with the answers to figure out where you need to make adjustments in your design, or set up the programming for your microcontrollers and DDR DRAM chips. A lot of that stuff's controllable today inside of the devices. They're getting much smarter, just like everything else. All right, manufacturing verification. Everyone has this done at some point in time. If you send out a board to a fabricator, you're going to have it validated by that fabricator to make sure there's no violations. They don't want to build the board and send it back to you and it doesn't work for some reason, be due to a yield function in the fabrication process. So they use a DRC tool to do that. Now, some companies may say we don't do enough designs per month. That's very true. Fine, you're at least having the fabricator do stuff. But on the assembly side of things, a lot of customers don't do verification on that side, and the CMs that they're using may be small and don't have the tools to do that validation. They'll try to do stuff visually when they get your design, but having a tool where I can just have the design rules, just like everything else I've talked about here, having something already set up takes me 30 minutes to a couple hours to analyze a design and come back with what those issues are, go fix them, and now when I produce that product, I'm ensured 100% that I'm going to have nice high yields through assembly and I'm not going to have any rework afterwards. That's what manufacturing verification is. These tools that your CMs could be using, Valor NPI leads the space in this market. They developed the market and they continue to lead that market and doing validation. If you go to some of the big CMs out there, they're using the Valor technology to analyze your designs. However, they're also charging you for that. So if you're sending out even up to 2 boards a month, it could be worthwhile for your company to start looking at bringing on this verification internally. Then you can turn things around even much faster. You can move the verification process up through the design phase. Instead of waiting till the board is done, I can validate parts in my library. I can validate the placement of my design and fix any issues that may occur before I ever get to routing and move on. And now my CM doesn't have to do that validation. They're not going to charge me that NRE. To do that, I'm saving money there. Plus, I know when that thing goes through their processes, it's going to work, and we're not going to have any issues with the design. It's kind of a hidden known fact out there that CMs don't always report back to you every little violation that they find when they do a DRC check on that board. They'll kind of feed some to you slowly. I mean, their business thrives off of you sending them new designs, right? So it doesn't always behoove them to be 100% honest, where if you have the tool internally, that is never going to be a problem for you. All right. So again, if you're interested in this type of technology, if you have this type of technology, great. You've taken that first big step into the industry digital twin design philosophy, and you're ahead of the game. But if you're not, by all means, look into this technology, see if it's feasible for your company to add this on, and again, be a hero and get to that point of where you're reducing your design schedules, helping reduce your design schedules for your company and get your products out faster to market. Mechanical stress analysis. So moving into the mechanical space, again, if you're a mechanical engineer and you're doing any of that, or you know the mechanical engineers at your company, hopefully they're using tools to analyze stresses in any of their designs that are going to be in an environment that could be under stress, either via thermal or physical stress constraints, you can simulate all of that now, or you have been able to for years, but you can simulate all of that right directly in the MCAD environment. The tools have been made very easy to use now. You don't have to be a specialist in doing meshing in order to get the model set up to do the simulation. The tools nowadays can handle a lot of this setup process for you automatically, so that the simulations can be done more quickly. But again, the whole idea is don't reduce costs, reduce design spends, ensure first pass success. You could even validate different materials instead of going with the material that you've used all along. You might be able to save money by switching to a different material that's less costly, but it will work perfectly fine in your environment. You just didn't know because you never had a prototype built in that material and were able to test it. But in a simulation environment, that's the great thing. You can do anything you want in a simulation environment. You can test all of that, different scenarios, and come up with better solutions. Like one of the big things in mechanical engineering that's really being pushed right now is generative design. It's kind of like the auto router of PCB design, where I can set up a mechanical design, I can define the load points in the design and the stress points in the design, and then I can have it actually tell me what that thing can look like. I can tell it what types of materials are going to be used, and it can actually morph that shape into something that could be stronger than what you're doing already. It could be lighter if your products have any weight requirements. It's a great way to reduce weight of that product. And take advantage of 3D printing technology out there today. That's what's really boosted or brought generative design into the mainstream. It used to be kind of a specialist thing out there. The technology's been out there for 10 years, but not very many people used it because the manufacturing capability of something that's been generated automatically isn't very practical. But with 3D printing technology, it is very feasible to design and create that content using that. So again, that's another simulation type environment application where you can optimize your design based on materials, weight of materials, and load points to give you a solution in the end. All right. Fluid dynamics, hopefully, again, if you're getting into thermal or you're doing any fluid related stuff, airflow, even if you're cooling a printed circuit board with a fan, that is fluid dynamics, being able to do that. Knowing how to cool that printed circuit board or cool the enclosure of that design, whether it be purely mechanical or, LEDs is really, really driving a lot of CFD analysis now, because the LEDs are very powerful. They're hot. They're very energy efficient, but they still get very warm. And simulation needs to be done to solve those problems. But being able to simulate an entire enclosure of your design, again, play around with different scenarios of how I want to try and reduce the heat of components in that design, whether it be doing something in the printed circuit board itself, using venting in the physical enclosure, or adding fans and blowers to the system to cool your design, different heat sinking mechanisms. It's very time consuming if you try to do that stuff by hand, where I can do all of that in the simulation environment. In most cases, I can do it directly in my MCAD environment to solve those solutions, come up with those solutions, and move forward with my design using CFD applications. And Mentor has a product called Flow EFD. It's like the hyperlinks of CFD. It's very easy to learn how to use. You don't have to mess around with all the meshing stuff. The tool has algorithms that build mesh for you automatically and let you move right into the simulation environment and get to what you want, the results. Review those results. Come up with a solution to fix the problem if an issue occurs, and move on with your design. So the other thing with simulation, mechanical or fluid dynamics, mechanical stress, is you can produce a higher quality product in the end, and you can even define or help test out your lifespan of your product, which can help your company decide what kind of warranty to put on the tool or your product. So if you could, instead of putting a blanket warranty of maybe 12 months or 3 years on that, you find out through simulation that, oh, you know what, our product can last for 5 years, and we're not going to really see, you know, a failure, a large increase in failures out there. Now you can put a longer warranty on your product. People will be more intrigued from you. That's a differentiator from your competitors. All right. Cable validation. Again, this is a tool. This is a design phase you may not be dealing with, but a lot of companies out there are dealing with cables in their design. If you're doing any type of box build where you have multiple PCBs or you have things you need to interface with on the exterior of your mechanical environment, being able to draw up a cable design in an environment like a schematic capture tool, have the intelligence built into the library to make sure I don't miss anything in how that cable is going to be built, being able to define how the cable is going to be laid out in both the 3D environment and the 2D environment when it gets built is a very powerful function that today is literally done with AutoCAD drawings or 2D drawings and Excel spreadsheets. So companies are starting to move into the modern age of using a modern CAD tool to do this. So if you were not aware of this technology, it's readily available out there. Today we have 2 different products in this environment, one called Vistas, one called Capital. Just depends on your level of complexity in the cable design that your company is making. But the tools are there to streamline and make the process of doing cable design way faster and more accurate than what you're probably dealing with today. And to recap, as you can see, there's a lot of technology out there that you may not have been aware of. If you were, great, you've done some research in the industry. But I can tell you right now, when I go out and visit customers, I mention these things, and 100% of the time there is something that I mentioned that design team did not know existed that could benefit them greatly in their design process. So taking advantage of all the simulation technology that's out there today can be a great benefit to decreasing the timelines to get your product to market. And I can tell you right now, if you're not taking advantage of that technology, your competitors probably are, and they're going to be producing their product faster, more reliable, and be in the marketplace first with some of the same ideas you might have. One of the analogies I kind of look at when it comes to all using simulation is, you know, for us that have been around a while, you know, cars back in the day, especially the American cars, may not have been reliable. Everyone's worried about the lemon car, or the cars weren't lasting as long. I think everyone should be noticing today that cars are lasting much longer than they did in the past. And the reason why, because car manufacturers are using simulation tools to analyze their designs beforehand and ensure that when that car gets put together, it's going to last a given amount of time. Obviously, our competitors overseas have probably been doing this a lot longer than the American market, and it shows in some of their product design. But it's seen in a lot of other things too. TVs, cell phones, you know, your computers are lasting a lot longer. You know, I just actually switched out of a computer that I was using not that long ago. I've had it for 7 years, and it still works the same today that it did 7 years ago. You know, 5 years ago, 10 years ago, you couldn't really say that about most laptops or desktop PCs. Something would have broke out there. So adopting that simulation technology to ensure your product lasts longer is highly advantageous and should really be looked into by your company if you're not already. So being more competitive in the market space, I mentioned some things about helping you determine, you know, the real warranty factor of your product. How long could it really last in the industry? Maybe we can put a longer warranty on our product, make it more attractive to a customer over a competitor's product. Reducing or determining product defects, or if you do produce a product and it has a defect, you know, people are on social media now. Social media can be evil. You know, you see it all the time out there with everything. When a major defect happens with something, people get out on social media and they say something about it, and that can explode. It can go viral, and it can damage or tarnish the reputation of your company, because you cannot control social media. It's an uncontrollable force that we just have to deal with now. So again, ensuring our products don't have any major defects is going to make your company look better in the long run. I don't know if anyone out there has had this happen, but you know, we've kind of all heard of the Xbox issue where they had problems. The Surface, Microsoft Surface machines had some issues at one time. Tesla has had some problems with things that could have been solved with simulation, or the digital twin philosophy of looking at all of the design process all the way through manufacturing, that nothing was going to change or be affected, or if something was affected, you know, what was it, and let's fix that before we move into the physical production and not delay things in our product launch. When we've given hard timelines to our customers and you don't meet those, customers get very upset. We're in a fast-paced environment nowadays. Everyone wants everything to move fast, fast, fast. All right. So let's see what kind of questions I have here. So relating to hyperlinks, are some of those tools available, you know, at a lower end? So a lot of people are worried about signal integrity tools being a lot of you know, very expensive applications, and they are to some respects. And then again, mentors leading that space. If anyone out there owns, say, a PAD Standard Plus suite, you actually have some of the basic hyperlinks tools in there if you were not aware. So the Standard Plus or the previous ES suite, or even PADS Professional product packaging or packages include things like analog simulation, some basic PCB thermal simulation. They've included some of this technology I've talked about. They include some basic signal integrity, so you can look at those signals now, or maybe 1 nanosecond, 500 picoseconds on your board, and see if you may have a problem. You can design your stack up in there. So yes, those tools are available. If you're using a lower end version of the PADS tools, you can upgrade into Standard Plus. If you're using Cadence products or Altium and you don't have that technology, by all means, you can migrate over, you know, into the PADS environments in order to be able to do some of this Industry 4.0 philosophy of analyzing your designs and not relying on physical prototypes to get built. So you mentioned CFD and Flow EFD. Is it what tools can that be used with? So the CFD tool from Mentor Graphics is actually, they're very CAD agnostic. They've partnered with all of the major CAD vendors out there. So if you're using Creo, you're using SolidWorks, you're using I don't think Inventor. Unfortunately, they have their own CFD tools, so they haven't really allowed much integration there. But they're usually, from what I've seen anyway, they're not real big in the electrical mechanical world. There are people out there using it, but they're not as big as SolidWorks and Creo and our Solid Edge Siemens tool, NX, Dassault's CATIA product. Those tools have integration where you can run the Flow CFD tools directly in the MCAD environment without having to go out to a third-party tool. Of course, there is a standalone version of the tool you can bring mechanical geometry into, but for most people, the mechanical engineers, they can just do that right in their CAD environment. They just need to buy the right version of the application. So the electrical sign-off tool, I've seen some advertisements out there. This is another question of this free tool called Hyperlinks DRC free. What types of stuff can that do? Well, the The MetaGraphics website, the PADS website, actually has a very good explanation of what free rules come with that. I think Hyperlink's DRC right now, if you buy the whole application, is up to about 33 design rules, I think 32 to 34 design rules that are built into the tool already. You just need to define the parameters for the rule to be able to use it. The free version comes with 8 of those. So it kind of gives you kind of a basis to, you know, start maybe checking some of your designs. By all means, it's free. You should go out there and take advantage of it. It's like using LT Spice or any other free PCB tool. At least try it. You know, you might find a problem with one of your designs using it. Again, I'll have links to all that on the YouTube channel when I post this archive out there. So from that, if you like the capabilities of that and you want to move up, there's actually a Hyperlink's DRC version for our PADS flow that gives you, it leaves out a couple rules from the full standard version. I think it's 30 design rules or something like that in the PADS version. But the great thing about that, the price is not there of the full application and having to be able to do development and all of that. So you can expand into that design rule set at a very economical price and start validating your designs using that application. All right. You mentioned stack-up design. Can I do stack-up design, or does PADS take advantage of the stack-up design from Hyperlinks? Currently, I don't believe you can import a stack-up from the Hyperlinks tool, but you can definitely create that stack-up information, and then you can very easily go type it in to the layer definition function inside of the PADS tool. Now, if you're using PADS Professional, yes, that stack-up header is actually built right into the CES environment inside of PADS Professional. So everything you do in that stack-up header is already defining what your board stack-up is in the first place. So can you send a link to the PADS Rural webinar? Sure. Yeah, we'll be sending, or there should be invites that have gone out already, but I can definitely, let's see here. I'll see all the people that are on this list. We'll be sending out a follow-up email afterwards, so you'll, and there'll be a link in there to, the future webinar that you can then register for that one as well. All right. I'm not seeing any other questions, so I think we'll go ahead and wrap it up here. I want to thank everyone for joining us today. I hope you've learned something about simulation technology that can take you out of that physical prototype build phase of doing things and doing it virtually using simulation, and speed up your design process, help you, design your products faster, and hopefully help make your company more successful. And again, you can be the hero of your company by reducing design schedules and producing a better product if you mention some of these tools and bring them on board and start using them. So thank you everyone for joining us today, and I hope you have a great afternoon, and we'll look forward to seeing you at our next Did You Know webinar series. Thank you very much.